Hello. In this video, I'm going to explain how I made this falling blocks animation in Godot 3D gaming engine. If you look up here, here's my scene. I've got 100 blocks, physical blocks falling, but I don't have that many objects over here. So I'll explain how I did that and where I started this from. Uh, First off, I started following a tutorial by BornCG. He's got a nice little tutorial. I'll link to it in the description below, where he makes this 3D game, simple game as a demo. Very nice tutorial, explains everything very well. Means very. You can go from beginner. I know programming, but I don't know Godot, so this is really helpful for me from the Godot side of things. But he also explains the programming side too. So let's start a new project. I'm going to recreate what you're seeing here without without having to create manually all those blocks. So new project. Let's quit first. We'll go talk to me. Where's the new project? There it is. Falling blocks. Put that in F. Go. Make a new folder. That'll work. All right, so we'll start. He explains all the how-to making the floor and blocks in the first video. I'm gonna kind of breeze through that. And again, the link below is his tutorial. So I'm gonna make a spatial node. We'll add a floor to it with another spatial node. No, wait, sorry, it'll be a static. The floor is a static body. And then on the static body, we'll add a collision mesh. Collision shape, and a mesh instance. Oops. There it is. Then we'll go in here and give this a cube shape, or box shape, I should say. Why is that big? Okay. And actually this goes into the static body too. Okay, so under the static body, which we'll rename the floor. We have the mesh instance, which I need a mesh. I'll make a new cube mesh. Okay, so there's my cube. Default size, collision shape is the default. Oops, undo. Oops. Okay, that's the right size. So we'll take this and raise it up. And undo. I have to select. Oh, this is the floor. So the floor I want to make bigger. Okay, so let's make the floor 60 by 60. And again, he does all this, explains it very well in the video series. And then the collision shape I'll have to extend. And in the case here, this is like a radius, the extent. So that, oops, what did I do? Reset. Okay. So if I zoom back now, there's my floor. I'm sorry, new Godot. So, okay, so that should give me a solid floor for things to land on. Now I'll add a new object. This will be a rigid body. This is the box. And we'll go ahead and rename that as box. I think that's what he calls it his. And actually, I think he calls the whole scene his level. We'll go ahead and change that too. Kind of matches the tutorial. All right, so we made the box. We'll add the mesh instance and the collision shape. We'll make the collision shape a box. Make the mesh instance a cube. Select the box and lift it up. give a little tilt. Whoops. I'm doing this. Okay, there we go. All right, and then play scene, and this thing should drop onto the floor if I did it right. I gotta save my scene. Okay. Well, sure, level. And I forgot the camera. Okay. We need a camera instance to see what's happening here. Add child node camera. Which way is Z? I think that's, well, first of all, camera, highlight it. We'll lift the camera up. Okay, it's looking that way, so I think I wanna. Which way is it looking? Okay, it's looking that way. So let me undo that. Pull it back this way. There's a little cone that comes out of it so we can tell where it's looking. This was easier the first time. We turned on the camera. All right, so let's see what that looks like. There we go. So there we go. So that is basically a quick run through of his first tutorial, his first video in the tutorial series. So we made a physical object and a static body for it to land on. And then what he did, he duplicated this. He did duplicate and call it was box 2. Highlight the box 2. I need to learn to scroll this thing better. Move box 2 up, maybe over, spin it a little bit differently. Duplicate that again. So now we have box 3. So this is really neat. But so now we have 3 boxes doing the duplicate thing. And there they are. And of course, I'm a DevOps engineer programmer, or used to be, and I'm like, oh, copying stuff. No, I want to program where I can make 1,000,000 of these things. I don't need to create duplicate every time. So that's what I set out to see if I could make these boxes spawn themselves basically and come into existence and manage themselves. So that's what I'm doing here. That's how I ended up with the little demo I showed you at first. Let's go ahead and delete these duplicates. We'll leave. Whoa, what did I do? Did I just duplicate it again? Delete. There we go. Yes. We'll leave the first one there. And we'll color the first one red. I have to give it material. And again, he shows how to do this in the second video, I believe, in his series. Make a material and change the albedo. All right. I'm just coloring that, so when I add the other boxes, you can tell the difference between them. So now I'm going to make a new script. I'll call it self-managed. Actually, it's trying to think of it as self-managed box. We'll call it that. It's going to inherit a rigid body. Is that right? That's right. And I'll go ahead and use the default template. So where'd it go? There it is. Make this a little bit bigger. So by extending rigid body instead of node, I'm basically starting with this script is equivalent to this box, which if I highlight here, it's a type rigid body, right? So it's already one of these, it's just not in the box, right? So I want to get a mesh instance and a collision shape added to it. So let's go back to the script, self-managed box. So when we come here, I want to say my mesh class. No, wait, my mesh is equal to mesh instance .new, which is pretty much the same thing as coming over here and adding, right-clicking and adding a child node. Almost. Actually, I got to add it to I can do add child my mesh. Oops. That should do it. And then I'm going to do var my collision is equal to collision shape dot new add child my collision. So that should put, save that. What else have I run this? This is not in the scene. I don't think this is going to work because I haven't put it in a scene or anything. Okay, it's just running the main scene. All right, so that's not what I just did. That was just running the scene over here. So now I've created the script, self-managed box. So I'm going to go back to the level. I'm going to add a script. I guess we'll do it this way. Attach script. It's going to be a different script than the one I just made. This is a script for the node. So I'm going to say var box. We'll call it. I'm worried about colliding with the other name. I'll say my box. My box class is equal to load. This is how I'm going to load that object, that file I created, that script I created. So if I come down here and highlight my self-managed script down here and grab this, I'm going to copy this path right here. So now my box class, and maybe I should, I'll just leave it like that right now. I think the right way to do this is call it my box class. Not that it really matters, it's more of a style thing. And I'll say var my box is equal to my box class new. And then, and again, we're in the top level node now. I'll add child my box. So that should, and I haven't set any settings, so I should just put a box at 0, 0, 0. Let's see what happens. No, I don't see it, but it may be covered up by the floor. Let's hide the floor. No, it's not there. Okay. Self-managed box, my box, add child, my box. So it exists. I don't have it. I didn't give it a mesh though. Okay. Right. There's no mesh in it yet, or collision. So my mesh dot mesh is cube. No, sorry. Yeah, I'll have to look. The box mesh is a new cube mesh. Okay. Cube mesh dot new. And then with the collision, I'll need my collision dot. And incidentally, this hierarchy and this inspector, this is basically a visual look into the code, which is why I can kind of look at this and see what I need to do. So I need a box shape. Wait. My collision shape. Okay. Boom. All right, time to cheat. Look at my code. Well, actually, you know what? I'll do it this way. The Godot is a nice help system. So I'm going to control click on this collision shape here to look at the properties. Now in the same window, I've got the documentation for the collision shape object to see what that collision shape is. Oh, it's dot shape, right? Yeah, here we go. Property description shape. So I'm looking for my collision dot shape is equal to box shape dot new. All right, so that should create, just as we did manually here, that should create a new cube mesh with default settings for the mesh instance and a new box shape with default settings for the collision shape. That's what the script is doing right now. So we'll save that, run the scene, and there it is. There it is right there. So we just created that with this bit of code here. So this little bit of code, whoa, what'd I do? Undo. Oh, I collapsed it. Okay. This bit of code right here duplicated this manually adding this stuff on this little box here. But what's great about it now is that's one of, well, first let's make this, let's put this somewhere. We'll do a translation or translation.z. Is this right? It's equal to, oh, okay, so 5. We'll put it up 5 high. Oh wait, yeah, this should work. Run the scene. No. What did I do? I did something wrong here. My collision dot undo. Apparently I deleted and saved. All right, that was is equal to box shape dot new. I think that's right. Live coding, fun. That, oh, right. That's actually closer to me. I said Y, or I said Z, I actually went Y. Y is the vertical dimension. Try that again. I don't know if you saw it. I'm going to make it much higher. We'll do 20. So my white block should be way up here now. Cool. So now let's make it translation dot y or x is equal to, actually we'll come up here and do a randomize first. We'll do some random numbers. So say randef. Our platform is 60 wide, so we'll do a times 60 minus 30. So that should put it somewhere on the platform. Then we do the same thing for the y. Oh, trying to copy that line. Control CV. So this should make it spawn randomly somewhere at height 20 above the platform. And I don't know if it didn't work or if it was just out of the camera view. Let me back up the camera some. So I can see the whole platform. Well, there it goes. It fell right down there. Why did it do that? Okay. Oh, I'm going mixing up Z and Y again. That's why. Okay. All right, so X and Z are the sideways dimensions. Y is the vertical dimension. So I goofed up there. So this should put it above the platform somewhere randomly. So then we run it over and over again. So now we have, in this little bit of code, we have basically these three items over here, it's the equivalent of those, except to duplicate it, remember I'm creating this from this level GD script, right? I can do, instead of 1 for x in range 5, and make the debugger happy, we'll put an underscore in front of that. So it's now 5 times, we'll create a box. And there we go, 5 boxes randomly spread around. 100 boxes. Without all that copy, paste. There's 100 boxes scattered all about randomly. So I like that. I like that kind of encapsulation and scalability. So let's do some other interesting things. Let's make them, because let's, what happens if I tilt the floor? If you go to the floor, let's just tilt that whole thing, see what happens. I mean, I'll make that sweeper thing later, but right now we'll just have them fall off the edge and see what happens. They just fall forever. Yep, there they all go. So if I don't want them to fall forever, let's make them say, hey, if I'm below a certain point, I'm going to respawn. So this is function ready. I think I'm going to move, say, func reset position. I don't know if I need an underscore for it or not. We'll just do it that way. Put that under here, and then we'll call reset position from there. So now I'm going to go to the process, and I'll say if translation vertical is y, oops, dot y is less than, say, -5. Then it'll do a reset position, right? So I'm using the process instead of the physics process. Either one will work, since, I mean, I'm checking a physics location or a physical location, but I don't think I need to do it I don't think I need to do it in line with the physics loop. The process loop I think is probably fine, but I'm not really good at Godot yet, so I don't know if it matters. So these guys now, when they go below a certain point, they just respawn at the top. Now notice they're kind of starting all go to the left increasingly. They're keeping their angular velocity, or their linear velocity, and their angular velocity actually. So they're spinning increasingly faster and faster, and moving faster and faster. So I think I would reset their velocity, which on a manual box, you know, you've got your inspector over here, and somewhere in here, there we go. There's linear velocity and angular velocity. So we can access that in code too. So each of these box, let's make a little function here, say reset velocity. And just for the grins, I'll go ahead and reset both angular and linear velocity. So linear velocity could be a new vector 3, 0, 0, 0. And actually the angular velocity is the same thing. And incidentally, whoops, what did I do? I hit the F1 key, I think. What did I do? Okay, here we go. So again, I'm doing this from memory and kind of looking over here, but if, again, this is a really very good documentation. I'm working, these properties belong to this object, which is an extension of the rigid body object. So if I control click the rigid body, I can look at what what properties I have, right? So there is linear velocity, explains how that works, and angular velocity is in there too, explains how that works. So again, nice little documentation built in. But these should reset linear and angular velocity. So if translation is less than 5, reset position and reset velocity. See what that does. So now instead of like increasingly going to the left and faster spinning, yeah, there we go. They're calming down. Now, interesting that their angular rotation is obviously keeping the same, as they're all tilted the same way. That's cute. So we can fix that too. Oops, what I do? Here we go, script. So we can add a function reset rotation. And that's going to be, what is that going to be? I don't remember, so I'm going to look. Control click. So translation is position. These are the properties: mass, mode, weight, friction, bounce, yada, yada, yada. It's not here, but I think that may be a property of a spatial node, a spatial object, because these inherit, right? So if you think about it, all spatial objects probably have, yeah, there we go, rotation. So the rotation degrees and rotation. All right. So I'm resetting rotation. So let's rotation. And I could do degrees, but 0 in degrees and radians is the same thing. Oops, actually no. Is equal to vector 3. 0, 0, 0. Or actually, what would be fun, I could just, yeah, you know what, I'll start with 0, 0, 0. We'll change it up a little bit. So they're tilted, they have angular velocity, now they reset. The rotation is not resetting to 0. Oh, you know why it's not resetting to 0? Because I didn't call it. So I made the function, but I didn't call it. Reset rotation. There we go. So I made the function, but I didn't call it. So now I'm calling it whenever we go below there. So now it should reset. Now they're all crooked. Okay, there we go. So now it's resetting the angular, the rotation too when it respawns. So let's do a little fun thing. Instead of making it all 0, 0, 0, first of all, come here and make a constant. Let's say circle is equal to 2 times pi. Pi is a built-in constant. So 2 pi radians is, that's basically 360 degrees. We could use a degrees to radians or function, but why do that when we can do a one-time calculation, right? So linear velocity, let's do angular, let's do rotation, the rand, float rand times circle. So that should make them in random rotations when they spawn. Or wait. Okay, when they respawn. Because I'm resetting rotation here, but I didn't reset rotation here. While I'm here, I'll go ahead and reset velocity. Although currently that's meaningless, but while I'm thinking about it. So now they appear jumbled at random rotations, random positions. Let's go ahead and add a random angular velocity. Let's make a new constant. Let's say rotate max. Say speed. rotate max. I'm going to use, this is the one-time calculation, so I don't mind doing this. We'll do, what? I don't know, 45 degrees? No, wait, let's do 5 degrees. I don't know how fast it is. So do angular velocity, randf times speed, rotate max, times 3. This is one of the, this rotation speed in each of the three, around each of the three axes. That's why there's 3 times. So now they should be spinning it at, whoa. I saw some spinning very slowly. Okay, so that number is probably not big enough. So let's make that number 50. Okay. We'll just take out the, we'll just make it 50 radians. Let's see what that does. Oh, that's a bit much. Wow. They're actually spinning so fast, they're kicking each other up in the air when they're colliding. All right, let's talk about 5 radians. That's a little over. All right, that I like. There are none going crazy. There are some that are kind of energetic. All right, maybe a little too energetic, but I can adjust it constant later. So now let's make them change their color. So to do that, we have to get into the box shape properties. Now, if you're in one of these named manual things here, you could, we could locate that, well, here we do reset color function, reset color. So if this were over there on the left, we could do collision shape dot, we could access it this way, but I found when creating things by code, you can't reference that. That's a name defined when you type that over there. But so what we'll have to do, is we create this cube mesh in order to access that albedo property. Instead of doing that, we'll do my cube mesh is equal to cube mesh new. And this way I can access this, and I can say my cube mesh dot name is the negative r is equal to we can call it cube mesh to match what's over here. Do I need the cube mesh? I'm confusing myself a little bit. So now I'll do the my mesh dot mesh is equal to my cube mesh, which is basically the same thing that I had before, except now I have a reference to cube mesh. I'm going to go ahead and set a name to mesh instance. All right, so now with those, I should be able to refer to this by name. So I should say mesh instance dot mesh Sorry, I have to think here. So this is mesh instance.mesh. I'm going to cheat, look at my code here. Material, spatial material. Oh wait, dot albedo. Albedo color. Okay. So albedo color is equal to for the moment we'll do a vector 3, 0.5, 0.5, 0.5. That should be like a gray, I think. I think it's going to throw an error, but let's see. Cannot set index name on value type string. 14. Okay, my cube mesh dot name. Okay, so this part apparently isn't needed. Yeah, actually, this isn't something I had. Okay. I can't tell that the colors are changed, although I don't think I actually called the color, did I? I did not. Okay, so it didn't error, but does it actually do anything? Yeah, I didn't like that. Invalid set, albedo color on base cube mesh with value type. Okay, what goes there? Cube mesh. Okay, mesh instance. That's the cube mesh, right? So that's a cube mesh, and the cube mesh has a property. Oh, it's a material. It's a spatial material. Oh, I didn't add the spatial material. Okay, okay. That's what I forgot. We've got to add a spatial material. So var my spatial material is equal to spatial material dot new. So the cube mesh had a all right, so there's mesh instance, there's cube mesh, then the material. So where's the material? All right, so I think material needs to go here because there's mesh instance. So we have mesh instance, and then inside the mesh instance is the mesh material. Oh, sorry, the mesh. And then inside the mesh instance is the material. Which doesn't currently, yes it does. Okay, there we go. The material inside the mesh instance. So there's material inside the mesh instance, and that's where the albedo is. So mesh instance dot mesh dot material dash albedo color. So that should be it. Let me stop the running instance, start it up again. No. Okay, so what I did the first time is I actually did an init section. This is my code for the original that you saw. And I didn't do it. I assigned the color inside the init because I had trouble reaching these deeper properties from the code without a variable reference. So, here's where I create the new spatial material with a name, and then I have access to that albedo color. I think what I'm going to do, because I'd like to be able to reset this later, because with doing it this way, I lose the reference to that value elsewhere in the thing. So I think what I'm going to try to do here is I'm going to create a variable up here. My spatial material. Is that what it is? Yes. Is equal to spatial material new. So that reference should exist whenever in any of the functions now. So I can get rid of that part. My spatial material. And I didn't add it. Hang on. I just realized I skipped a step down here. I'm curious now. So I made the spatial material. So my cube mesh dot material is equal to my spatial material. So, okay, that may be why I couldn't find it. It wouldn't exist. It didn't exist yet. So let me see if that works. No. Okay. So back to the original plan. Comment that part out. We'll make the variable up here. So I have a variable reference to that spatial material even after we get out of ready. Stop the simulation. Start it again. Oh, right. But now instead of doing this, I want to hit my spatial material and change the albedo color there. Albedo color. Oh. So it's got the right base now. So I've got an existing thing, but it didn't like the type vector. So let's go look at the spatial material. I'm looking for the albedo color. Oh, I'm using the wrong type of value. So color. And that might have been part of the other problem, but we'll leave it this way for now. So this would be a color. Whoa. Oops. Got a obsessive compulsive here. The last one should be alpha, although it didn't seem to do anything in my case. All right, so this should make a bunch of gray blocks, finally. Yay, gray blocks. Okay. So now let's randomize that. Randef. So yeah, so that's the part I just took a long time on the video, and the part that gave me trouble the first time around was finding references to these deep values when creating things for script. Because when you create it over here, you can just find these things a few ways by that name. But when you create it by script, you have to either set the name or save a variable reference to that value you're looking for, or that object you're looking for. So I just made that random, so we should have a bunch of randomly colored cubes now. All right, there we go. So we have a bunch of randomly colored cubes that spawn themselves above the platform, but currently hard-coded. Um, and when they go below a certain point, they respawn, they teleport back above and drop again. So that was really um, what I was aiming for is like, okay, I can use code to, and now that we have it all in code, if I want 500 of these things, level.gd, we'll make a constant up here, num blocks. That's currently at 100. We'll make it 500, right? So 500 blocks. So again, you can see if I wanted 500 blocks of something, physics, I don't have to go over there and duplicate 500 times with a little bit of work and so forth. And this really, there's a self-managed, make it a little bigger. That's all there is to it. So neat. Next, I'll go ahead and make the wiper, the sweeper. So let's put this back at 100. Let's put the floor back straight. Oh, probably shift. No? Or we'll just go to the matrix rotation 0. Now it's straight. So now what took me a minute or two, and at first I thought the wiper should be a static body, like the floor. But even though, like, if you look at the floor, it's a static body. There is a field here, constant angular velocity. That doesn't do what I want it to do. I can't make a long wiper and make it a static object and have the angular velocity make it move. It doesn't move the object. The description of this field, well, heck, we'll go look at now. But basically, it's supposed to impart motion to physics objects, but it doesn't actually move the spatial object itself. So a rigid body is going to have mass and its own physics. But it turns out what you need is actually a kinematic body, like you make with a player. A lot of Googling to figure that out. Add child node, kinematic body. So even though it's not player controlled, kinematic body can have infinite inertia. So we're going to need a mesh. We'll use this plus mesh instance and collision body for it. Collision, type it in. So that goes as up here. So mesh instance will make this a cube. We will we'll make it extents. Nope, not 30 by 30, just 30, one dimension. We will lift it up one. Where is the handle? Up one or two. Oh, it's size. Okay, this is the mesh, so I want 60 for the size. It's the collision shape where I want the extent of 30. So somewhere in here I should be able to see little handles. I gotta figure out how to slide this thing. Oh, nope, undo. Oh, Okay, I think I didn't move. Let me put, oh, undo. This is the meshes, and I think I raised the mesh distance and not everything else. I think I need to raise the whole kinematic body, right? So now if I do collision shape, there we go. I can see the extents on the collision shape now. Yep, there, that little dot is the extent of the collision shape. So now I know the shape matches the mesh, which matches the kinematic body relocation. So let's just run that and make sure it shows up. Yep. And there may be another way to do this, but I just added a script. Add script, add script, add script. Actually, let's, no, I was going to rename it wiper, but we'll leave it this way. So do a function physics process, because I do want the physics of this one. And okay, I was going to look at my code, but I'll look at the, I had to look a lot of this stuff up. Process. Oh, this is the rotating sweeper. Rotate Y. Okay. And I had, okay, so I'm curious about the rotate. Where is that rotate command? Actually, you know, all right. Go back to the kinematic body, do rotate Y. And we'll go ahead and do a const speed rotation. Was that 1 degree I did, I think? So rotate Y, speed rotate. So rotating around the Y-axis. Every physics process loop. So does that do it? There we go. And that plus the manual coloring of the floor and the kinematic body is where we are for the falling blocks demo. And I've watched this thing until my screen blanked out too many times. I'm a little bit too proud of this, but Godot is fun. You know, most people I think are approaching it from they know some design and not programming. I'm approaching it from a very I don't know the art side of it. I don't know the models, the mechanics, the 3D engines, but I know programming pretty well. But it's kind of nifty to approach for this angle. And so just keep that in mind. If you want to make a lot of something, you can make, instead of duplicating items over here, you can create a script which, you know, again, look at these blocks. I mean, they're picking their own position, their own color, and they're resetting themselves. And you know, to encapsulate this better, we probably want the environment, the level, to tell it, hey, I want you to spawn in this area, and the floor below which you respond is such and such. You know, so there could be some communication which would make this block a little more portable. But you know, I over design things as a programmer. That's just what I do. So I hope this was helpful. Please let me know what you think. Like and subscribe if you want to see more, or give me a comment. And thank you very much.